Hello and welcome to Algebra 1 with Miss Betsy. I'm glad you're with us today. We are continuing our work with radicals. Today what we're going to be doing is learning to divide radicals and what it means to rationalize the denominator, how we do that. If you're using the same text that I am, we are in Algebra 1 for Christian Schools. It's published by Bob Jones University Press. I'm using the second edition. I'm in Chapter 10, Section 4 on page 406. But first, our lame joke for the day, and I really just couldn't pass this one up. Can you tell me what type of what type of lights Noah used on the ark? Well, of course he used floodlights. What else would he use? So I've written a couple of definitions up here on the board that I wanted to first review the product property for you, and then secondly, introduce the division property. We have been working with roots of numbers that are not perfect square roots or perfect cube roots, and we learned that there was a really neat trick called the product property that would allow us to simplify roots of numbers that were not perfect squares or perfect cubes. Right here we have the square root of 50. There's no number that if you use it as a factor twice, that it will give us the proper square root. However, we can write 50 as the square root of a product of 25 times 2. We can factor 50 into 25 times 2. Now, we have the square root of this product, square root of 25 times 2, that is the same as the product of the square roots. Using our product here, we have the square root of a product rule here, property here, we have the square root of 25 times 2. You can break that apart into the square root of 25 times the square root of 2, and of course that makes our problem possible to complete at this point, because we now have that the square root of 25 is 5, so our solution to the square root of 50 is 5 times the square root of 2. It'll take you a little bit of time, perhaps, to realize that this is a simplified form, but this is what we're looking for when we simplify roots of numbers that are not perfect powers, perfect squares, perfect cubes, whatever. I'm going to step out of the screen just for a minute. My lighting is changing more all the time. And that won't be quite so bad a glare. Now we're back to just the normal reflections and shadows that we have. Similarly to how you can separate out the roots of a product, you can do that same thing when you are working with division. Let's say that we wanted to find the square root of 16/25. Well, the square root of 16/25 happens to be 4/5. Because what is it that we're looking for when we find a square root? We're looking for one number that when used as a factor twice, you find the original problem. So 4/5 times 4/5, because when you multiply fractions together, you multiply numerators and you multiply denominators together. But maybe you don't want to have to think, okay, 4/5 times 4/5. That's easy enough for you to say. Well, just similarly to how you could take the root of individual factors in here, we can do the same thing with the division property when we have the square root of a fraction. We can split that up so that we have the square root of the numerator divided by the square root of the denominator. And now all of a sudden that jumps out to you. It's very easy. All of you know that the square root of 16 is 4 and the square root of 25 is 5. So the square root of 16/25 is indeed equal to 4/5, and it's not a difficult computation to make at all. So this is what we're going to be doing when we're dividing radicals, and then we're going to see what does it mean when we rationalize the denominator. Well, we know what fractions are that have not been reduced to lowest terms, and we know improper fractions, and we know mixed numbers. Well, what's it mean if we want to rationalize a denominator? Obviously, a denominator is the bottom part of something we recognize to be a fraction. Weird looking fraction, that's why we call it a rational number. And our rule tells us that you cannot have radical symbols in the denominator. No radical signs in the denominator. So what does that mean? We're going to have to denominator. So when we rationalize it, that means we only have a rational number in the denominator. We have to get rid of that radical sign. So what we're going to learn to do is expand on our understanding of what square root actually is, what cube root is, so that we can multiply by some expression equal to 1. Remember, as long as the numerator and the denominator are the same, the expression can look just as weird as all get out, but you still have a value that's simply equal to 1. So what we have when we multiply, in this example here, the square root of 2 times the square root of 3 in the numerator, the square root of 3 times the square root of 3. Multiply numerators, multiply denominators together. And okay, it's not looking much better yet, perhaps. Square root of 2 a perfect square? Square root of 3? No. What we have right here is we're taking the product of two roots. We can put all of that together underneath that radical symbol. Square root of 2 times 3. What's the square root of 3 times 3? Aha! That's starting to make sense, isn't it? Because the square root of 3, well, the square root of 4 is 2. 2 times 2 is 4. The square root of 3 is just the square root of 3. The square root of 3 times the square root of 3. Let me put this extra unnecessary step down there. Square root of 3 times 3 is the square root of 9. This gives us as our answer the square root of 6 divided by 3. This right here is what we mean when we say rationalize the denominator. There's a radical symbol over here in the denominator, which means it's an irrational number. Now, there is no longer a radical symbol here. This is a rational number, so this is rationalized. And this is what we mean when we talk about rationalizing a denominator. This is the simplified form. The denominator has been rationalized. What you do when you rationalize a denominator is you multiply by some expression that's equal to 1 so that you end up with a perfect square on the bottom or a perfect cube. So you're going to look at these and you're going to say, I started with the square root of 2 divided by the square root of 3. You told me to rationalize it, and I ended up with this mess down here, the square root of 6 divided by 3. How in the world did I simplify it? understand you looking at this and looking at this and saying there's just not a whole lot of difference there. It doesn't look any more simple to me at all. But this is our definition of what simple is. You can't have that radical sign in the denominator. You had it here so it wasn't simplified. Even though this is a bigger number in the numerator, you have eliminated the radical in the denominator, which is what you need to do. Okay? Let's go ahead and look at a couple of examples in here and work through them. And these are more things where you just have to spend the time necessary to learn how to do the computations. Doing a marathon taping session, so I've got to wet my whistle occasionally. I'll just go ahead and step through these examples. Let's say that we want to do this problem, square root of 3 divided by the square root of 6. Well, that's meaningless. First thing we want to do is write this in fractional form, if you will. Square root of 3 divided by the square root of 6. It's not necessarily real helpful yet, is it? But we can use our division property that tells us that this is the square root of 3/6, can't you? Okay, and now you have a fraction that you can simplify. We have the square root of 1/2. Okay? I don't know a number that when you multiply it by itself you get 2, so we still have problems. Okay, back to the square root of 1 divided by the square root of 2. Okay, we can take the square root of 1, but we end up with 1 divided by the square root of 2. Is this answer all right? No. What do we need to do? You cannot have that radical symbol in the denominator, so you need to rationalize it. What does it mean to rationalize the denominator? It means multiply by whatever you need to so that you don't have that radical symbol in the denominator. So the second part of this problem, and let me just go ahead and carry it up here to this next column over here, is to rationalize 1 divided by the square root of 2. If you need to think of it as any way, maybe it's slightly akin to reducing a fraction. You get down to a fractional form and it's not in lowest terms. You're partway there, but you're not done. When you're working with dividing radicals, you get it down to what looks like lowest terms, but you've got a radical symbol in the denominator, you're still not done. We multiply by the same square root. Square root of 2 times the square root of 2. We're going to multiply the numerators and multiply those denominators together. So what do you end up with? You have the square root of 2 divided by, now let's look at this, it's a little bit different way to look at it. 2 times 2 is 4, but it's also 2 squared, isn't it? So maybe this will help your brain think in a slightly different way. When the index and the power are the same, the square root of 2 squared is just 2 by itself. This right here is the solution that we're looking for. When it asks us, say, divide 3, the square root of 3, by the square root of 6, our simplified, rationalized solution is the square root of 2 divided by the square root of 2. And it just looks a little bit different. So now what if we wanted to do this? Square root of 3 divided by the square root of 12. And the more of these that you practice, the more you will keep your eyes open and you'll not fall into their little traps. Because Because there you might think, oh, well, if I want to get that square root of 12 out of the denominator, I'm going to multiply the numerator and the denominator by the square root of 12 over the square root of 12. Be thinking about how you can manipulate the problem legitimately, make your work easier. 3 and 12 have a common factor, don't they? So why don't we use our division property that says this is the square root of 3/12. Go ahead and reduce 3/12 into 1/4, isn't it? Square root of 1 divided by the square root of 4 is equal to what? 1/2 is your answer. What is 1/2 times 1/2? You think, how in the world can 1/2 be equal to, but be the solution to the square root of 3 divided by the square root of 4? Well, let's look at it. Square root is one number that is being used as a factor twice. 1/2 times 1/2 is equal to what? It's equal to 1/4. 1/4 can be written as an equivalent fraction with a denominator of 12 by multiplying the numerator and denominator by 3. So that's exactly what we're looking for. It's just a different way of looking at things. This is new material. It's going to take a little while for you to get your minds wrapped around it. You have to get your minds wrapped around it though. Radicals are with you for the rest of your life as long as you're doing math from Algebra 1 on up. So let's go ahead now and look at the square root of 2 divided by the square root of 75. See what we can do. Square root of 2 divided by square root of 75. First, see, can you simplify, or can you reduce it somehow first? Can't do anything with the square root of 2, so we're just going to leave that. However, 75 is the square root of 25 times 3, isn't it? Remember, you learned back a few sections ago how to simplify the square root of 75. Square root of 25 times 3 gives you the square root of 2 divided by, this is the step that I'm leaving out, square root of 25 times the square root of 3, 5 times the square root of 3. 5 times the square root of 3. So our solution to the square root of 2 divided by the square root of 75 is square root of 2 over 5 times the square root of 3. And you go, bleh. It's a mess. Are we finished here? No, we're not finished because there is a radical symbol here. What are we going to multiply by to rationalize that? We're going to multiply by the same quantity here, that's the same radical. So we're going to multiply the numerator and the denominator by the square root of 3. Multiply the numerators together. What do you get? You get the square root of 6. Multiply the denominators together. 5 times the square root of 3 squared, or the square root of 9. So you have the square root of 6 divided by 5 times the square root of 9, 5 times 3. 5 times 3 is 15. This is your answer. Square root of 2 over the square root of 75 simplifies down to the square root of 6 divided by 15. Nothing else you can do. I am so sorry if you look at that and you look at this and you say, it's not any more simple to me. New way of thinking, some new processes in algebra that you just need to work with until you've gotten these competently under your belt. So now, let's see. For those of you who are in my class, you're going to need to look at page 409. You're supposed to be reading your book anyway. You're supposed to be getting all of this material on your own. I'm just here as a huge resource for you. But there is a little algorithm, tells you what to do if you're going to rationalize the denominator of a square root. And they're showing you how to do this, giving you cookbook step 1, step 2, step 3 at the top of page 409. So let's go ahead and look now at some roots that are not square roots, and you'll see how you can rationalize the denominator with them as well. And we have the cube root of 8, cube root of 8 divided by the cube root of 16. Now the first thing that we can do here is we can use our division rule that said this is the cube root of 8 over 16, which becomes the cube root of 1/2, which is the cube root of 1 divided by the cube root of 2. Cube root of 1, 1 times 1 times 1 is 1. You cannot find the cube root of 2. Plus we have a denominator here that has a radical symbol in it. In order to rationalize it, that radical symbol may not be in the denominator. So what are we going to do now? We're going to see, let me see how they do it. When you're looking for a cube root, you're looking for a factor, one identical factor that's used how many times? 3 times. Cube root requires that same identical factor used 3 times. So we want to rationalize this expression, 1 divided by the cube root of 2. We already have one factor of 2. We need 2 more factors of 2. Now hang with me. This might be really weird. We're going to multiply it by the cube root of 2 squared, which is 4. The cube root of 2 squared. In your book, they do use 2 squared. Why am I doing this? Because I want to multiply what's underneath the radical symbol, 2 times 2 times 2. I'm looking for a perfect cube. What's another way that you could have written this? You could have also written this, shown your work, 1 times the cube root of 2 times the cube root of 4 over the cube root of 4. That's the way I prefer to do it because I didn't work as much with exponential notation, and that just makes better sense to me because I'm going to have the cube root of 2 times 4, which is 8. Either of these 2 ways are equally legitimate. This is an alternate method, alternate work. Okay. Now, what are we going to have when we multiply those numerators and those denominators together? We're going to 1 times the cube root of 2 squared. That becomes the cube root of 4 divided by the cube root of 2 times the cube root of 2 cubed. Didn't need to rewrite that there, but I did. It's the cube root of 4 cube root of 2 squared divided by the cube root of 2 cubed. Cube root of 2 cubed is 2. So the cube root of 4 divided by 2 This is the solution to the cube root of 8 over the cube root of 16 becomes the cube root of 4 over 2. I'm going to let you look at that just for a section. Second. See, I can't even speak. At this time, some of you, you're going, tilt. I can't comprehend this. Or some of you are saying, man, this is really easy. I've got it, click, click, click. Okay, both of those responses from you probably aren't right. In all likelihood, yeah, you can get it. You've got to sit down and take some time. You've got to work with it. You've got to put some effort into it. But you can do it. And then on the flip side, you think, oh man, this is simple. I totally understand what's going on. Yeah, you do, because you're following my process here in class. Following my thought process. Here's that video for you. But you've got to take pencil and paper and put some work to it yourself so that you can see that you truly are comprehending what we're doing in this section. Let me do another one now where we have added some variables into our problem. As long as I can read my book. Make sure that after you write the problem, you're taking the time to go back and ensure that you copy the problem correctly. This says, simplify this. The square root of 18 a squared b c cubed divided by square root of 9. Let's see, the square root of 9 ab cubed c squared. A b cubed c squared. Let me make sure. A squared b cubed c squared. First thing we want to do, let's write this division this way. 18a squared b c cubed divided by 9a b cubed c squared. We want to make sure that we keep positive exponents. Okay? Let's go ahead and see how we can reduce this. We have a factor of 9 in common. We've got a 1 and a 2 left. I'm not going to put all these little slash marks in there. It makes my mind crazy. If you want to see the slash marks, you can go ahead and look in your book. 18 and 9 divide. I'm going to have a squared divided by a, b divided by b cubed, c cubed divided by c squared. So let's see what happens. Still inside the radical symbol. 18 divided by 9, I have a factor of 2 in the numerator. A squared divided by a, that gives me a to the first power. Can cancel a factor of b from the numerator and the denominator. And I have b squared in the denominator. Now with the c's, c cubed divided by c squared, I have a c in the numerator. Everybody take a second and look at that. Make sure you see what I've done. A squared, I have two factors of a in the numerator, one in the denominator, cancel a pair of factors. I have an a remaining in the numerator. I have one b in the numerator, I have three b's in the denominator, leaving me b squared in the denominator. Three c's in the numerator, 2 in the denominator, leaving me one factor of c in the numerator. Now, my division property says that can become 2, the square root of 2ac, divided by the square root of b squared. Can you tell me what the square root of 2ac is? No, you can't. But, however, you can tell me what the square root of b squared is. And that is simply b. Believe it or not, this is the solution to our original problem. You're past the point of being able to look at something and say, oh, it looks like a logical answer. You have to understand the process that you're using to be able to arrive at your final solution. Okay, let me go ahead and look at page 410 and see if I want to do one more example for you. And you know what? I'm not going to do this one. I'm going to let you go ahead and look at this, work through the problem on your own, okay? Hang in there. You guys are going to be able to do this, but it takes you a fair amount of work. Don't be afraid of the work. And realize that if you're spending far less time on your homework than your teacher is prepping, that maybe you've got a problem and you need to ramp up your homework time, okay? Have a good week. I'll see you next time.